Welcome back. This may just be a quick little video, but I thought it was interesting, possibly. Working on a little PS4 controller, a DualShock 4 controller. Belongs to a family member of mine. But the complaint was it would only work when it was plugged in. When it was connected via USB to the PlayStation, it would work normal. As soon as you unplug it, it would die. And sure enough, that's when I checked it. It would work when it was plugged in, but the battery it would not work off of. So opened it up and checked the voltage across the battery, and sure enough, it was 0. So I unhooked it and thought I would charge it off to the side a little bit, like so, and plug it back in there, and maybe the onboard charger would take off, kind of like a switch. But nope, as soon as I plugged it in, it was measuring like 3 volts, off the charger, off my supply. As soon as I plugged it back in, 0 volts. So I get to checking, and this is the part where I may have to put the camera down to show you. See if I can. I don't know if I can do this with one hand. Too frustrating. Across the battery terminals, right back here. Yeah, pretty much like 1 ohm, like a dead short across the terminals. So, I'm not real familiar with these things. I don't know if something usually goes bad, if there's a protection diode, I don't know. But what I'm thinking about doing is I have, if I can reach it over here, recently picked up a FLIR infrared camera. And I've used it before on some repairs, and it does come in handy when you're looking for shorts. So I'm thinking about feeding a little DC voltage in with my bench supply and seeing what gets hot. Should be interesting. Let's find out. Well, here we are under the FLIR infrared camera. I had to solder some leads so I could connect this connect this power supply. I am set on about 1 volt at 1 amp. And let's see if something gets hot. Oop, something over here. Something down here in this corner. Yep. 0.5 volt, 1 amp, getting hot. It's something on the back side of the board, or the top side, depending on how you look at it, right in here. Let me do that again. Yep. Okay, so we gotta get this board out. As far as I can tell you, there's nothing there on this side of the board, the side that I can see. Oops, hit the wrong supply. Huh. Very strange. Let's see, where is that? Right in there. Okay, that off. That's the only thing I see getting warm. Okay, let's take this board out and see what's in that area. Well, here we are under the microscope, and I think we can see where the problem is. I'm going to guess at some point some moisture came in around this analog stick here and gave us a little bit of corrosion right there. I'm going to guess that capacitor has shorted. I haven't touched it yet. It looks rather nasty though. So let's go ahead and touch it, see what happens. some of this goodness off of here. Maybe the capacitor's not bad. Maybe it was just that bridge right there. That corrosion bridge that was the problem. Maybe a little spritz of alcohol. Where's my precision toothbrush? Alright. Alright. Now what are the chances that that short is now gone? Maybe I'll just measure right across the capacitor there. Nope, she's not gone. There's actually two capacitors there in parallel, aren't there? Well, what happened? Okay, now the end cap's just in bad shape. Alright, what about this one? That looks to be in parallel with it, unless my eyes are playing tricks on me, but it doesn't really read shorted there. But it does there. Gonna see, do either one of these look like they have a crack in them? See if we can zoom in here and look at them real close. Can't really say I see a crack in them, but you know what? There is still some corrosion under that one. I'm gonna say that big one needs to come off, and let's see what happens after that. Alright, we have our lead suspect out and on the mat here under the microscope. And it looks pretty bad, doesn't it? Let's see. Yep, she is shorted. From this side you can see it looks really cooked. I guess this maybe on the side it was up, I don't know. It didn't look that bad before, but you look at it like that, yeah, she's shorted. Okay, so now just a quick check. Take that capacitor out of the way. And let's see if I can get this under the microscope. Maybe too close. There's the battery terminals where I was injecting voltage. Let's see if we still have a short there now. Short is gone. All right. All right, so I think we found our problem. I think you can live without that little capacitor. It's just a little bypass capacitor in there. I have no idea what its value was. I got a feeling it'll work just fine without it. So let me put it back together and see if it does anything different now. I'm pretty sure it will work a lot better. Alright, well, I've got it back together enough to test. I want to see, earlier this would draw about 0.47 milliamps, or 0.47 amps, 470 milliamps, kind of like a switch. But it wouldn't draw, of course it wasn't charging the battery. I expected to draw more than that if it's actually charging that battery, which was dead. So let's see what she does now. Hmm. 0.48. That's not really any more than it was. Let's see if the battery voltage is going up. 3.59. 96, 97, 98. So the current in did not increase dramatically, but the voltage is going up, 3.6 volts and climbing. Interesting. I just noticed the battery has, it has stamped on it maximum charging current of 1 amp. So I thought maybe they were, charging it. They could have been charging it at a faster rate, but apparently they don't. That looks good. Then again, it's also possible that this battery is low, so it's like trickle charging it. There could be a battery management IC on this controller that's trickle charging it right now because it's less than 3.7 volts. And then maybe it'll take off and charge it faster once it gets to be at a comfortable level. But that looks good. We're not shorted anymore across the battery, and we appear to be charging 3.615 and climbing. Okay, I think we're good. I'm just going to watch this for a while and see if that voltage goes on up to around, I guess, close to 4 volts. And that's all I've got. I just thought it was an interesting fault and a good excuse to use my infrared camera. I don't get enough chances to use it. So I hope you enjoyed it. If you thought that was interesting, educational, or entertaining, please give me a thumbs up, and I'll see you soon in the next video. Bye.